Okay, welcome everybody. Okay, homework number 4 has just closed on Blackboard. Now that was a long one. You have a few extra problems with that assignment. Homework number 5 is a shorter one. So a little bit of a respite there. It's due on Friday. If I remember correctly, there's only 5 problems. And today we're going to be covering the first part of present worth analysis. We'll also do some problems on Wednesday. So you can get started on homework 5 after today's class, but there may be a couple of problems on there that only make sense after our in-class exercise on Wednesday. Also, I want to put it on your radar that the first exam is coming up. You've got about, I guess it's 9 days until exam 1. I'll give you some more information about that. It'll be obviously here in this classroom during our normal class time, but I just wanted to make you aware that it might be a good time to start summing things up and reviewing the material to prepare for the exam. Okay, so today we're going to be moving into chapter 5 in the book, and thus far we've been mainly doing some theory stuff. We've been learning how to calculate the effect of the time value of money. But now we're going to be moving into decision making and comparison. And that's really the heart of this course, is being able to make decisions based on economic information. And so present worth analysis is one of the first ways that we're going to compare an option A, option B, and then decide which of the two alternatives is better in an economic sense. So before we start talking about the least common multiple method, are there any questions related to the announcements? No. Okay. So we're going to be focusing on decision making and analysis. And the difference between the present worth method and the present worth analysis is that in the present worth method, you're just finding out what's the value in present terms of some sequence of cash flow over time. So it may be as a table, it's maybe a diagram, but I'm giving you a series of numbers in a series of times, and I'm saying take it all to the present and find out what's the present equivalent. In present worth analysis, you're doing that to one or more alternatives, and you're saying yes, an option is acceptable, no, an option is not acceptable, or if two options are acceptable, you'd be choosing from among the two alternatives. This figure comes from your textbook, and it's just kind of an illustration of the thought process that leads to decisions. And the point that's being made in this figure is that a company will go through a decision-making process that starts with brainstorming. And so this is a cloud, and I guess it's raining ideas from the brainstorm. And the initial part of sorting those ideas is grouping them by projects that are viable and projects that are not viable. And that may not be initially an economic decision. It may be a technical decision or an ethical decision, just kind of screening the things that we want to analyze. What are the economic consequences versus just ignoring some ideas? Like no homework. Well, that's not really viable. Or free salary for everybody, nobody has to work. Not viable. So there's viable decisions that then would be sorted among two different categories. There are situations where you only need one solution, and so you'd have to pick which one is best. And those are mutually exclusive alternatives. And so an example of a case where you may have a mutually exclusive alternative is if you're deciding what kind of eye surgery to get. You're only going to get eye surgery from one person, and so you're choosing among alternatives, all of whom could provide a similar service, but you only need it from one person. On the other hand, there can be independent projects where any of those options and all of them potentially could be accepted as long as they're all economically profitable. And so you have to sort from among these two different kinds. You have to understand, in other words, are we just going to pick the best one, or are we going to choose everything that meets a certain criteria? And then, with a cash flow diagram, you'd sort them into the types of alternatives that generate a positive cash flow over time, a profitable project, that's to say. And so that would normally be the case for private companies. But in the case of government entities or nonprofit organizations, then there may be options that are revenue alternatives. And a revenue alternative is one that, a cost alternative is the one that doesn't necessarily generate profit because it's being done for other reasons, like maybe public safety or protecting the environment or providing recreational opportunities. Those are all examples of projects that maybe you do even though they're not generating a profit for a company. So in decision making and analysis, we're going to be using the present worth method of taking all the cash flows to the present and then applying a decision criteria. And so a mutually exclusive alternative is one where you'd only select one of the option, whereas independent projects you can select more than one. And whenever you're choosing from among alternatives, you should always assume that doing nothing is one of the choices that you've got. And sometimes if all of your options are going to yield a negative cash flow or more costs, and you're representing a company that should be seeking profits, then maybe you just choose the do nothing alternative. So a revenue project is one that generates inflows and outflows. It's going to have costs associated, but it brings revenue, whereas a cost alternative is only going to have expenses, and it's assumed that all of the projects that you're comparing have expenses and don't generate revenue or the same revenue. So decision criteria. So decision criteria is when you're making a decision, you have to know what's the rule that you're going to be applying. And in present worth analysis, the method is that you take all of the inflows and outflows over time and then you discount it to the present using the MAR. And does anybody remember what this abbreviation stands for, MAR? Yes.
Minimal acceptable rate of return?
That's right. It's the minimum acceptable rate of return. And so that's the rate of return that in most organizations is tied to their borrowing costs. In some other organizations, they set it as a policy decision that they don't want to initiate any projects that yield a rate of return less than some number. So what you're doing in the present worth analysis is you use the MAR and you take all of the cash flows to the present, discounting at the MAR. So discounting is, remember, the opposite of compounding. Compounding is when amounts are getting bigger as you move forward in time. Discounting is when amounts are getting smaller as you move backward in time. So it's where you're moving future amounts back to year zero. Now, here's the decision criteria. If you're only going to choose one option, then you choose the option that yields the highest positive present worth. So it makes sense that you'd want the most profitable option if you're only choosing one. If you're choosing more than one option, meaning the independent projects where you can pick as many as you like, you should keep selecting all of them and agreeing to them as long as the present worth is greater than or equal to zero at the MAR. So what that means is that you're going to have profits when you discount those profits at your minimum acceptable rate of return. So a present worth of zero is okay if you're discounting at the minimum acceptable rate of return, because what your company is saying is this interest rate is acceptable, anything less is not acceptable. So when you have a positive present worth, that means that you're making more than the MAR. So a present worth of zero, when you're discounting at the MAR, means that your project only returns the rate of return that's equal to the minimum acceptable rate of return. And of course, not mentioned here, the decision criteria is if the present worth is less than zero, then you'd reject the alternative. So anytime the present worth is negative when you've discounted at the MAR, it means that the project is not going to be profitable. Now, in the economics and the time value of money, we can't compare these two options because they occur over a different time horizon. As you can see, option A is some investment that yields a return over 6 years, whereas option B is some investment that yields a return over 9 years. Now the problem is that some of these dollars are in year 1, some of the dollars are in year 2, and so on. But option B lasts longer. And so you can't compare a piece of equipment that lasts 6 years to a piece of equipment that lasts 9 years unless we use some method to equalize them. And so the least common multiples method that we're learning today is abbreviated LCM. It's a way to ensure that you compare apples to apples, so to speak, that when you have two options, one that lasts long and one that wears out more quickly, the way that you can compare them is by repeating until they terminate in the same year. And so let's go back to the initial cash flow diagram. I'm going to flip back and forth so you can see how the cycle's been repeated. So in option A, you buy it at time 0, then you have 6 years of operation. The first year ends in year 1. The second year ends in year 2. The third year ends in year 3, and so on and so forth. Now, what you're going to notice when I flip to the next slide is that you buy the item again at 6. And the reason why you buy the item at 6 and not at 7 is if you bought the item at 7, then you'd have a gap year of no revenue. And what that means is that the item wouldn't be in service. And so you have to purchase the thing again. What we're saying is we're going to buy whatever option A is. It's some piece of equipment. We're going to buy it 3 times in cycles. We're going to buy it at year 0, at year 6, and year 12, and then the cycle ends at 18. And so in order to ensure that we have this item in service the whole time, we buy the item at the end of the 6th year. And so this revenue is from the first item that we bought. It's from the last year of operation of cycle 1. And then here we are, we're buying the item again at the beginning of cycle 2. And then this revenue is associated with the first year that we've operated the second item. And so then the same thing happens in the third cycle. You have to buy it at the end of the last year of cycle 2 so that it's ready to go from the very beginning. And then here is that first year of operation in the third cycle, and it terminates. Now, why don't we buy it again in year 18? Well, because if we bought it again at year 18, then we'd be having all this revenue coming to us in the future, and then it wouldn't be ending the same time as option B. The reason why this is called least common multiple is that the least common multiple when you've got 6 years and 9 years is 18. It's 2 cycles of 9 and 3 cycles of 6. That's how you can get it so that they both stop at the same time. So does that make sense to everybody, what we're doing here to solve the dilemma? The dilemma is you can't compare options if they last a different amount of time. That's the dilemma. And the solution is repeatability. So this repeatability assumption is just saying, well, assume that you could buy it again a couple times, and then the cycles do end at the same time frame. And so it's not a different number of years anymore. Now it's the same study period. The study period is 18 years. Okay, so any questions so far? So the least common multiple method assumes that you're going to be able to buy this item a second and a third time, and that it's going to be the same cost. Now that may not be accurate, and so if that's not the case, then you need to make an adjustment. Maybe you manually adjust to say, well, I assume the item's going to be a little more expensive the second time, and even a little more expensive the third time. So it's easy to correct if you need to, although there are certain things that it's probably a pretty good bet that you can buy for the same price. And one example of that's computer hardware. I mean, a good laptop these days costs you $1,000. Probably a good laptop in another 6 years could be bought for $1,000. It's a good bet that you'll be able to get, like a good business laptop for about the same price. Some things go up in price, some things stay the same, but repeatability is built into the LCM method. And if you know that the prices aren't going to be the same, then you should manually correct your cash flow diagram. The other thing that you need to consider is if you're projecting 18 years into the future, it may be that the revenues also change. And so you might need to do kind of a reality check and adjust the revenues over time. Okay, so we're going to apply this method today. And we have an in-class exercise. The first problem is just applying the present worth analysis for two pieces of equipment that both last for 8 years. So you'll draw a cash flow diagram, and then you'll use the 10% table, which is on the back, to find the present worth of both options. And then the second problem is this one. It's on the back side of the paper. And unfortunately, it says to do it at 4%. And I didn't give you the 4% table on the handout, but here it is. I'll put this up on the screen so you've got it available when you're working on the second problem on the back. Okay, on the first problem, we're comparing Mitsubishi and Hyundai, and the handout asks you to draw the full cash flow diagram, not the net amount. And so I've put on the whiteboard just the net amount. So let me show you the full cash flow diagram. We have our initial purchase price of $250 for the Mitsubishi versus $205 for the Hyundai. And then an annual revenue amount of $95,000 for the Mitsubishi versus $89,000 for the Hyundai. And then the annual expenses. We have maintenance charges and fuel costs that are outflows. And then there is a salvage value where you're taking the item and you're selling it for scrap, or maybe selling it on the secondary market. But we've got a single future value as a salvage at the end. And so what we're trying to figure out in the second part of this example is which alternative is better. If we assume that our minimum acceptable rate of return is 10%, then of these two options, are either acceptable? Do we have an option that will give you a positive present worth? And if so, which one? So what we're trying to do in the present worth method is take the cash flow, take all of the amounts to times 0 and combine them. And so for the Mitsubishi, we have an annual series of 43,000, take it to P. And then the single future amount, take it also to P, meaning 0. And so you're going to have find P given A for I equals 10%. Wait, is this one 10%? Yeah. 10% and n equals 8. So you'll look up the factor for that, multiply it by 43,000, and that tells you the present equivalent. And then you'll also do find P given F, I equals 10% for n equals 8. And that takes this single 55,000 from year 8 to the present. So you're not calculating the ratios, you're not calculating the factors, you're looking them up off the table that's on the back side of the paper, and you're multiplying that factor amount by the annual series or the future amount, and you're finding the present equivalent. If you want to check your numbers, they're up on the screen. So we would select Mitsubishi because the present worth of the Hyundai is below 0. And so that means if your interest rate is 10%, then the present value of those future profits isn't enough to justify the initial expense. But in the cases of the Mitsubishi, what it means is you're going to earn more than 10% return on this project. You're going to earn the 10% return and then also an extra $5,058. So what that means is, if your borrowing costs are 10%, you'll be able to pay the bank their share and keep some profits for yourself. But if this MAR doesn't necessarily represent your borrowing costs, if it represents just a policy decision, then you're going to have more than 10% profits for yourself. So when you discount things at an interest rate, anytime it's more than 0 for the present worth, it means that you make more than the MAR. And so that's the case here. The decision is select Mitsubishi because the decision criteria says for mutually exclusive project, pick the option that has the highest positive present worth, and that's the Mitsubishi for this one. All right, now for this problem, when you repeat the cash flow diagram, it should look like, let's see, did I sketch it out? No, I didn't sketch it. I might have that somewhere else. So let me show you the solution for this one. Okay, so option A, we have the 11,500 that's already at the present, and then we discount the 5,000 annual revenue at 4% for 18 years. And so this P/A is taking all of the revenue to times 0. And then there's also the purchasing it again in year 6 and year 12. And so we treat those like future amounts. So when you multiply the amounts by their respective factors, we get that the positive present value of option A is $35,525 in comparison to option B is going to be less. So we have the annual revenues, the future amounts, and the present value will just be $24,321. Okay, that's it for today. Again, a thank you to those of you who showed up on time. I really appreciate it when you're in class before it begins. That helps me out. So I will see you on Wednesday.